All right, well, good afternoon, seventh grade. We are moving along here in chapter 5. And this lesson here is broken up into two parts. So the first part is what we're going to be doing today. And it says, solve the proportion, explain your choice of method. You're not really going to have to do this, explain your choice of method, but you are going to have to solve the proportion. When we talk about solving a proportion, we're essentially meaning we look at something like this. Now, there's different ways that we can solve it. One of the ways of solving a proportion is just to think of it as an equivalent fraction, where we think, okay, what did I do to 6 to get 9? Well, that doesn't really work real well in the multiplication table. So if that doesn't work, thinking about equivalent fractions, we do what we call cross multiplying, where the idea that whatever 9 times w is equals the same thing as whatever 6 times 6 equals. Well, we know that 6 times 6 is 36, so we could say 36 equals 9 times w. Well, now I'm just isolating the variable by dividing both sides by 9. And 36 divided by 9 is 4. And sure enough, w equals 4. All right, let's move along here. 2 over 7 equals x over 28. Well, when I think about equivalent fractions, I can think, well, I know that 7 times 4 equals 28. So I'm going to do 2 times 4. Well, 2 times 4 is going to give me 8. So then I know that x equals 8. Moving right along. 12 over 10 equals a over 15. Okay? Well, I'm going to show you another way to do it, and because this is a good example, because this fraction is not in simplest form, okay? And I can't do 10 times something to get 15. Now, I could do the cross-checking, 15 times 12, and make that equal to 10 times a. But another way to do this is to simplify this fraction. And these numbers are both divisible by 2, so 12 divided by 2 is 6, 10 divided by 2 is 5. It becomes 6 over 5 equals a over 15. Well, I know that I can do 5 times 3 to get 15, so I would do 6 times 3 to find whatever a equals. Well, 6 times 3 is 18, so I can be confident that a equals 18. All right, moving right along. 12 over 5 equals 6 over y. Well, when I'm thinking, what did I do to 12 to get 6? I see that I divided by 2. So I can say, well, I'm going to do 5 divided by 2. I'm going to think of that 5 over 2 as a fraction. 5 over 2. That's okay, because that's in simplest form. If you actually plug 5 divided by 2 into your calculator, it might tell you that it equals 2.5, and that's okay. Or I can also take this and turn it into a mixed number. 5 divided by 2, 2 can go into 5 twice. If I take 2 into 5 twice, there'll be 1 left over. I get 2.5. All right, 2 more. Here we go. X over 8 equals 7 over 10. Well, 8 doesn't work real well with 10. 7 over 10 is in simplest form. So this looks like to me that I'm going to be doing some cross multiplying, where the idea that 10 times x, which is going to be 10x, has to equal the same thing as 8 times 7, or 7 times 8. Well, that's 56. So 10x equals 56. So essentially, I am plugging into my calculator 56 divided by 10, because to isolate x, I'm going to divide everything by 10. Now, if you plug that into your calculator, 56 divided by 10. Don't enter in 10 divided by 56. You have to put the 56 in first. Divided by 10, that's going to tell you that x equals 5.6 is what that's going to work out to be. All right, last one. Y over 10 equals 3 over 5. Well, I know that to do 10, to make 10 5, I have to divide by 2, which means that y divided by 2 equals 3. But as we know, when I'm going the opposite direction, I'm going to do the opposite thing. just like 5 times 2 is what makes 10, 3 times 2 is going to give me this number here. And that, sure enough, y is going to equal 6. All right, that's solving proportions. Talk to you later, 7th grade. Bye.